Hello everyone, my name is Amruta Naina from Sri Venkateshwara College of Engineering. Today we are going to discuss a topic from embedded systems, that is the characteristics and quality attributes of embedded systems. So firstly, let us discuss the characteristics of embedded systems. Embedded systems possess certain specific characteristics. These are unique to each embedded system. Some of the important characteristics we are going to discuss today are the application and domain specific, reactive and real-time characteristics, operates in harsh environments, distributed, small size and weight, power concerns. So firstly, let us discuss the uh, application and domain specific characteristics. Each embedded system has a certain functions to perform, and they are developed in such a manner to do the intended functions only. They cannot be used for any other purpose. For example, the embedded control unit of a microwave oven cannot be replaced with an air conditioner's embedded control unit, because the embedded control units for microwave oven and air conditioners are specifically designed to perform a certain task. Also, an embedded system control unit cannot, it developed for a particular domain, say telecom, cannot be replaced with any other control unit designed to serve other devices like consumer electronics. Reactive and real time. Embedded systems are in constant interaction with the real world through sensors and user defined inputs, which are connected to input port of the system. Any changes happening to the real world are captured by the sensors or input devices in real time. The control or algorithm running inside the unit reacts in a designed manner to bring the controlled output variables to the desired level. Embedded systems produce changes in output in response to the changes in the input, so they are generally referred as reactive systems. Real-time system operation means the timing behavior of the system should be deterministic. The system should respond to requests or tasks in a known amount of time. A real-time system should not miss any deadlines for tasks or operations. It is not necessary that all embedded systems should be real-time in operation. Embedded applications or system which are mission critical, like flight control systems, anti-lock braking system, ABS, that we use in our automobiles, are real-time system applications. Then operation in harsh environment. So let us discuss how embedded systems work in a harsh environment. So the environment in which an embedded system deployed may be a dusty one or high temperature zone, or an area subject to vibrations and shock. System placed in such areas should be capable to withstand all these diverse operating conditions. The design should take care of the operating conditions of the area which the system is going to implement. For example, if the system needs to be deployed in a high temperature zone, then all the components used in the system should be of high temperature grade. Also, proper shock absorption technique should be provided to systems which are going to be commissioned in places subjected to high shock. So power supply fluctuations, corrosion, and component aging, etc., are the other factors that will be taken care in those kind of conditions. So next one we are going to discuss is the distributed. So the term distributed means that the embedded system may not be part of larger systems. Many systems of such distributed embedded systems are a single large embedded control unit. For example, an automatic vending machine. It contains a card reader, a vending unit, etc. Each of them are independent embedded units that they work together to perform the overall vending function. Another example is the automated teller machine, that is the ATM machine. It contains a card reader embedded unit responsible for reading and validating the user's ATM card, transaction unit for performing transactions, a currency counter for dispatching or vending currency to the authorized person, and a printer unit for printing the transaction details. We can visualize these as independent embedded systems, but they work together to achieve a common goal. Another typical example of a distributed embedded system is a supervisory control uh, control analytic data acquisition as SCADA system used in control and implementation applications, which is physically distributed individual embedded control units connected to a supervisory model. So a small weight and size. Product aesthetics is an important factor in choosing a product. For example, when you plan to buy a new mobile, you may ta- you make a comparative study on the pros and cons of the products available in the market. Definitely, the product aesthetics will be one of the deciding factors to choose a product. People believe in the phrase "small is beautiful." Moreover, it is convenient in handling a compact device than a bulky product. So next, the characteristic we are going to discuss is the power concerns. Power management is another important factor that needs to be considered in designing embedded systems. The embedded system should be designed in such a way as to minimize the heat dissipation of the system. The production of high amount of heat demands cooling requirements like cooling fans, in which in turn occupies additional space and makes the system bulky. Select the system according to the low power components like low dropout regulators and controllers or processors with power saving modes. All power management critical constraint in battery operated application. More power consumption, the less battery life. So now we are going to discuss about the quality attributes of the embedded systems. Quality attributes are non-functional requirements that need to be documented properly in any system design. If the quality attributes are more concrete and measurable, it will give a positive impact on the system development process and the end product. The quality attributes in any embedded system development are broadly classified into two: operational quality attributes and non-operational quality attributes. So, what are the operational quality attributes? Operational quality attributes represent the relevant quality attributes related to the embedded system when it is in the operational mode or the online mode. The important operational quality attributes are response, throughput, reliability, maintainability, security, and safety. Now, let us see what are these. Response is making sure the system has some quick response to what are the inputs we are giving. So it gives you an idea of how fast the system is tracking the changes in the input variables. It is not necessary that all embedded systems should be real time in response. So the next one is the throughput. Throughput deals with the efficiency of a system. Throughput can be defined as a rate of production or operation of a defined process over a state of period. The rates can be expressed in terms of units of products, batches produced, or any other meaningful measurements. Throughput is generally measured in terms of benchmark. Reliability is a measure of how much percentage you can rely upon the proper functioning of system, or what is the percentage susceptibility of the system to failures. Reliability is defined using two terms, that is the mean time between failures, that is the MTBF, gives frequency of failures in hours, weeks, or months. Mean time to repair, that is the MTTR, specifies how long the system is allowed to be out of order or following a failure. The next thing we are going to discuss is the maintainability. Maintainability deals with the support and maintenance in the end user or client in case of technical issues and product failures, or on the basis of routine system checkup. Maintainability can be broadly classified into two categories: scheduled or periodic maintenance, and the maintenance to unexpected failures.